Okay, great. So let's start.
Thanks.
So this will be the agenda. So we'll start with analyzing an algorithm, given algorithm, how we can analyze, uh, uh, and we'll see what all kind of other asymptotic notations are there, which we'll be using for analyzing an algorithm. So if you see data structure, right, it is a very big topic, and this is what I have divided into certain subsets of that. And then next, after analyzing, we'll see some of the mathematical functions or parameters we use in our algorithms. And then slowly we'll get into arrays, and then we'll see bitwise operators, searching and sorting, recursion, strings, matrix, linked list. So stack, queue, and whatever I'm talking, right, it is not very restricted to any programming language. These are all applicable to all the programming language, whichever language you are familiar with. But I will be using some code snippets, which will be from the Java code. So, I'm not going to execute that code and explain to you, but it is just captured for only for the purpose of logic, so that you people can understand the logic. Okay. So let's start with our introduction. So the highlighted ones are right. So these are all the 4 topics which I wanted to cover today. I will be a bit faster because I have a lot of things to cover, and there will be some quiz in between, so which I will be asking you guys. And if you have any questions, you can interrupt any point of time and clarify upfront rather than waiting till the end. I hope all guys put yourself in a mute so that we can have a smooth session. Okay. When we say analyzing an algorithm, right, what exactly that? So basically, we will be trying to understand how a particular algorithm behaves, right? For example, let's assume that person A has written one same algorithm in some different format, and the person B has written in some different format. So when you want to compare both the algorithms, both the functions based on the same algorithm, right? So how will you find that? So basically, what we can do is like we can execute that algorithm on one particular particular machine, right? And then there's another algorithm, another function which is based on the same algorithm, right, on some different machine. Basically trying to figure it out which of the functions are like behaving, how they are behaving with respect to the space as well as with respect to the time, right? How much time they are taking, how much space they are consuming, all that factors. So what happens, right? Space wise it's fine. With respect to time, so even though you are executing the 2 functions, or let's assume that same function on different intervals of time on the same machine, so it may have a different results because the machine on which you are executing, right, it depends, like if it is not executing any other task, what is the RAM size, all that parameters may vary or change based on the time. So we may not get exactly like a proper answer or exact numbers. For example, let's assume that you have written some function and then you want to calculate how much time it is taking, and keep executing that in a batch and see that you won't be able to, most likely you won't be able to get exact time in each iteration. The time will be varying even if you have a small function as well, because the computation, right, on a machine depends upon a lot of parameters, right? What other processes are doing and how busy the machine is during that time, and there are some networking related issues, all that things comes into picture. So basically in such scenarios, what we do is we use certain syntactic notations or certain parameters we use to understand, and basically with that respect we analyze the algorithms. For example, let's assume this case, right? This particular case, what we are doing is we are trying to find output of for example, let's assume I have passed some number, n number, so I want to find the from starting 0 or from starting 1, what will be the sum of that particular number. For example, like n is 3 here, then the sum will be 6, right? 1 plus 2 plus 3, like that. So if you see the function, right, so you can see that the return value is doing n into n plus 1 by 2, right? So there could be some other ways, like you can start with the for loop for starting with the I equal to 0 and I less than n, right? And then keep adding it to a sum variable and then finally return the sum. So this is somewhat mathematical logic here. So which usually what it does is like it is n into n plus 1 by 2, which is nothing but finding a sum of that particular number. And if you see this with respect to analyzing an algorithm, right? So you can see that it takes that instruction, right? The instruction can be, if you see assembly language, it can be number of instructions, or based on different programming language, right? The same instruction may have, like varying length of code. But when we talk about instruction, right, it is a single execution with respect to the code, or with respect to what I can say is like the way you look, or the way we analyze the program. For example, when I say return n into n plus 1 by 2, right? If you split this, you may have some 3 instructions, right? One will be like doing a plus n plus 1, and then the second iteration will be like the output of the n plus 1 will be divided by 2, and then third will be like sorry, not 3, 4 actually. Third will be like multiplying n again with the output, and then finally it is returning. But I just clubbed together just to show that, but these are all constant operations, right? So I just clubbed together. When I say a single instruction, it does mean that just one operation. So what we are trying to do over here, okay? And let's assume the second function here. First function 1, anyway, I have already explained. Function 2, doing the same thing with some different way, right? As I was explaining earlier. So we have a for loop here, which is iterating from 0 to n. And then in each iteration, you are adding that number. So it also does the same thing. But what is the difference between these two functions, right? Both are doing the same job. But they are not in same nature. They are different in nature, right? One is doing a constant operation. This particular one is always doing a constant operation, whereas this particular one is iterating over a loop. Okay, let's assume that n is some large number, let's assume that some million or billion number here. And if you see the return value, right, it is still doing the same operation. For example, let's assume it is a 1000, right? So n 1000 into 1000 plus 1 by 2. Right. So this is the constant operation. But whereas function 2, how it is behaving? So it has to iterate from 0 to 1000 iterations. And then each iteration, it has to do a sum, right? So I hope you are understanding, right, how we analyze the algorithm. We try to understand how many operations, right, it is being doing. So we call it as order, right? I will explain more on that. Okay. So yeah, so we call it as order of growth. How the algorithm is, like behaving or executing, in what order. Okay, for example, in this case, it is a constant operation. It is doing let's assume that it is doing a single operation. Okay, so in each, whatever number you pass, irrespective of that number, it will do a single operation. When I say single, it is just a single line. Just assume that, don't get into a complete operation. Okay, and when I say function 2, right, so it depends upon the number of n here, but it is not depend upon the number of here, the order of the function, right, not depending on the number of n here, because it is a single operation, whereas this function depends on the value of n here. So the number, more the number, this will going to take a more time, because it has to get into this particular iteration, right? So I can say this is taking order of n, because it varies with the value of n, but whereas this is taking order of 1, because it is taking only one operation, right? So this is a bit clear. Okay, so so this is the mathematical formula. Let me see if I can write something. Sorry, horrible. In Mac it is a bit difficult. Pen.
You can look for annotations in this Zoom meeting. You can try that also.
Yeah, that only I was trying.
It'll be in that Zoom controls when you have shared your screen. Or in the left bottom corner, there is one pencil icon.
Yeah, okay. This one, right? Okay. Okay, fine. Yeah. Yeah, fine. This much is fine. Okay. So here, this is actually n square. So I could not make it n square. So I just wrote 2n2. So basically, let's assume that this particular function, growth of the function, order of the how the function is behaving, right? Order of growth. So it is 2n square plus 5n plus 1. So basically, you have some for loop inside another for loop. So which is nothing but n square, right? Order of n square. And then the same thing will be executed twice, means the same for loop inside for loop, again for loop inside for loop. So 2 times you have. Finally, you have another for loop after that, which is being executed 5 times, like 5 times for loop, for loop, for loop, for loop, one after another, right? Not inside, it is one after another. When it becomes inside, it becomes square. Okay. And for loop or like I'm just giving an example, like any loop or any thing which is doing a certain set of operations. For us, it is like n number of operations, and then some constant, like some constant operation which is being executed for one time. Okay. So we call it as function order of growth. So it is 2n square plus 5n plus 1. Okay. Similarly, another function may have for loops. There are 6 number of for loops there, and then there are 2 constant operations. So this will be represented like this. But the interesting fact is that we don't consider all these things. This looks like a very complicated mathematical function, right? So generally, when we say order of growth, right, we try to do two things, okay, which I have listed here. First, we actually ignore the lower order terms. For example, when n square comes, right, so multiplied any constant with n becomes a lower order. So I will tell you what all things will become lower order. So we ignore these things. So now our function is 2n square. Okay. But again, the second thing is that we try to ignore the leading constant as well. So we try to ignore these two also. So basically the order of growth of this particular function is n square. So this is what we consider, because we try to consider the largest operation in this particular function. Similarly, for example, order of growth of this g of n function is it can be pretty simple, right? We try to ignore the lower order terms as well as the leading constant. So it becomes order of n. Okay. So now the question you ask, right, which terms are lower order? So lower order terms are like this. So first it is a constant, and then log of n. So I will tell you how you compute a log of n, right? When I go ahead with my slides later. And then this is the lower order for log of n. Sorry, this notation is indication of that this is a bigger order growth compared to the earlier one, compared to this one. Similarly, this is n of n raised to 1 by 3. Sorry, not easy to write here. Okay. And similarly, this is n raised to 1 by 2, which is lower order for n. And this is again n square, n raised to 3. And this is 2 raised to power n, something like that. So n raised to n, this is so not so easy. Okay. So these are all the lower orders. Okay. I hope let me go ahead. Okay. So now we have something called as asymptotic notations. Okay. Let's take this example here. So basically what we are trying to do is we're trying to calculate sum of elements of this elements of array, right? So you are given an array of integers. So you have to find out sum of all the elements in the array, right? So what we are doing, so we initialize the sums, which is a constant operation, and then we are iterating in a for loop. So this is nothing but int I equal to 0, I less than n, I plus plus, something like that. Okay. So and then what we do, we add each iteration, each element from the array, right? We try to add into a sum. And now you see what we are doing. This is the constant operation 1, and this is also constant operation which is taking order of 1. So this is also order of n, but order of 1, sorry, but this is order of n, right? So this is the order of n. So what is the order of this particular function? So it is n, right?
Order of n.
Yes, it is the order of n. Correct. Again, next is something like this. Okay. what we are trying to do here is that we are trying to perform some calculation and then return based on that value. For example, what we are trying to do here is that if array length is even, so we don't do anything. But if array length is odd, right, then only we do a sum. So now here, how you calculate what is the order of this particular function. So order of the function is depends upon the array length, right? Correct. So in this case, here there is another point which I just missed. Okay, let me just cover that. So here, irrespective of the array length, your function order of the function remains the same. Okay, the function is expected to grow with the same order, with the order of n. But here it is not like that. Based on the array length, right, the order of the function may have a constant operation, which is this, or it may have the same thing, right? The order of n.
Correct.
So it varies. So we have something called as best case or the worst case here. So the best case, when you say, it can be like single operation. In worst case or in normal case or worst case, whatever you call, we may have like order of n. Okay. So there are two things came here, like best case as well as a worst case scenario, right? Okay, let us see how we represent all that things. Okay. There is another thing called as average case also. Average case in the sense like this is the fixed thing which is always going to happen, right? So what we saw here, this is the average case. Always we know that these are all things will going to perform. So this is the average case. We can say like order of growth is exactly order of n, because always it is the case. It is the average case. But in this case, we have a best case as worst case as well. Okay, so there are some different notations, and we try to always represent with respect to the worst case scenario, not the best case or the average case. Okay, so always we try to represent with the worst case, and we have three annotations here. So we have something called as BIGO, which is which will be represented as exact or upper bound. For example, here, right, in this function, if you take this is the exact. Sorry, this is the exact. So if you represent function of f, right, it is 1 plus like order of n plus 1. But what we use only the sorry, I gave in this case, right? So it can be this or it can be this. So but what we do, we always try to take order of n. This is the worst case, right? So that is the worst case scenario. So it is exact or upper bound. So it can be exact or it can be upper bound. We have something called as theta, which is also annotated notation. So this is represented as like this, big O, and theta is like this. This is just O, and this is something like this, theta, and omega is something like this. So these are all notation. But in exam point of view, you can only concentrate on big O. So big O only they will be using, because that is the one which will be used by many examiners. And the other two things, right, theta and omega are not focused much. But if you are very sure that the algorithm is going to take only this much amount of time, then theta is being used. But the example which I am showing, or the scenarios which you do a Google search and find out, right, will have a simple algorithms which are not that complicated. So you may have a theta value available there, and you could able to represent that. But in real scenarios, we will have a very complicated algorithms, like generating a RAC algorithm, or having some complicated matrix related operation, all that things, which will have a very complicated algorithm based on the previous results. The next result will be next chunk of loops will be computed, and all that kind of things, right? So in that scenarios, so big O only will be used. But in this case, right, for example, here this is exactly theta of n, because like only this many operations will be performed. You also can represent with a big O of n also. There is no problem. But always try to understand more with respect to big O of notation. But if you are very sure and very confident, then you also can tell that this is the theta of n. But don't try to over smart or confused with the examiner when we start digging more with the theta. If you don't know, then he'll try to understand more, and then if you may a slip of tongue of yours, and may get like become complicated later point of time, right? So it will be difficult for you. Just concentrate more on the big O. Okay, so I will just give some example where you can use theta and where you can use omega. But I recommend you to read more on the big O part of it. Okay, so big O, when we say it is exact or upper bound, so that represent that will be represent with the big O of this, something like this. So when I say order of the function is n, right? So we say big O of n, something like this. Okay. So let's consider this example, linear search. What you're doing here, you have an array, you have the length of the array is n, and then the search element is k. So what you try to do is like you try to iterate the complete array and look for the match here, right? The element of the array is matching to a key here. K is nothing but a key here. And if you found a match, you will return the index of the array where the element is available. Or if the element is not at all present, so you return -1. So in this case, you have a 3 scenarios here. The best case scenario that the element is present in the 0th location, right? Here, so you found it in the first place itself. So that is the best case scenario. What could be then average? Average can be the element is exactly present in the middle, right? That could be an average. The worst case scenario, the element itself is not at all there in the array. So you search completely, but you did not find. So your array itself is over, but still you could not find. And then finally you have to return this -1, right? So basically what I'm trying to say is the worst case scenario is nothing but your order of n here. So big O of n is the worst case scenario. So whenever someone asks, right, what is the growth of this particular algorithm, you can always say it is the big O of n. Okay. Okay. We have something called as exact or lower bound, right? Quick sort, you guys know, right? So how quick sort we do? We basically try to divide an array. We have a pivot element. Based on the pivot element, we divide left side and right side of the array, and then recursively we jump to a left side or the right side on array, and again keep dividing further down until we find one or two elements, and then you try to sort that elements, and then the recursion will like fall back, and then fall back to the caller, and then caller fall back to the original caller, where exactly you will rearrange the elements, and then you become your array become or the output become a sorted thing, right? So which is nothing but a quick sort. I will not get into more detail. I think you understood. What I'm trying to say, why it becomes n log n, right? So basically, it becomes log n because every time you are dividing an array, right? Let us see how you are doing this. So you have this array length here. Let us assume that, and your pivot element is here. How the quicksort works, right? So what it does is, right, it divides this particular array to two smaller chunks, like this one here and one here. Okay, and then somewhere some element it finds a pivot, and again this division will continue down, and finally you have two elements only. So you know what to sort here. Again here also two elements. So this will fall back to the caller here somewhere who has called. Again this will fall back to that caller, like this it will go up, and finally you will have at the end of the time you reached here, right? So you will have sorted again. Here you have to sort because this side you have sorted and this side you have sorted with respect to the pivot element, and after that you have to sort this. So basically there you need to do big O of n time. And then how you got log n, because every time you are dividing the array 2 times, right? So in every iteration you are only doing the half of operations, and that you are doing for n number of times, right? Because this division will go till the last element. So that this is how it becomes n log n. I think I am not sure whether you understood this, but I can't write here quicksort how that is, but if you see the quicksort algorithm, right, you will understand why it becomes n log n. Log n is because every time you are dividing the array. So let's assume that you are dividing array by 10, then it becomes log of power 10. Okay. And in case if you are dividing by 2, it is log of power 2, right? Okay. Okay.
So on that case, it won't be like log of power n in this case.
No, you are dividing by 2 right here. So in case if you are dividing by
Okay.
n, yeah, so here you know you are dividing by 2 to 2, right? Exactly half of half. So that
Oh, okay.
it becomes log of 2. But in case
Okay.
if you're dividing by 10, 10, 10, right? 10, 10, 10 chunks, then it becomes log of 10 because next iteration you'll be again dividing by 10 like that. So
Okay, got it.
that is how it is. Okay. Okay. So the next one is that exact bound. Exact bound in the sense like we know like we are going to do only this much work. For example, let's assume that some game is there, so which we are going to play, where whatever the like operation you're going to perform next, but the initialization, right, will happen for all the players, right? So the initialization time, we can say it is a theta. This is a pretty simple one, where like whatever the result is of the game, right? I know like if I get out in the first iteration, but the time which I took initialization will remain the same, right? So that way, you can say that the time remains the same. So that we represent as a theta operation. But don't worry, this will not be as much, but I'm just covering the theory part of it. Okay. So let's analyze the loops here. I think I already covered. So this is take this, if someone asks what is the order of this particular function, you can say big of n, right? Any doubt? No doubt. Okay. So what about this here? So you can ignore the constant work here. And not only big of n, this is a theta of n, because like you're going to do constant work here. So there is not much, but irrespective of what the function is doing, but it is going to iterate for n number of times, that's for sure, because the constant work is representing that for all the elements you need to do that work. So it is theta of n. Okay, but don't get too smart, just say big of n is also fine. Okay, and here, so this is nothing but I equal to I to the power c. Okay. Okay, and there is some programming error here. It should be 1, otherwise the loop will be infinite. Okay, so what you are doing, so you started with I equal to 1 and you are trying to compute till n, but in each iteration, what you are trying to do, you are trying to increment the I with some constant value, right? So here I was mentioning, right? So logarithm of some number will come. Here what you are doing, so you started with this particular n element, and your next iteration, right, you're not going to consider n minus 1. But what you are going to consider, you are going to consider, for example, let's c is 2, right? So I equal to 1, c equal to 2. So next iteration, it becomes 2. Next to next iteration, it becomes 4. So you are again dividing to a smaller chunk, right? So again, when you are dividing with a smaller chunk, it becomes logarithm value. So if the c is 2, so it is log of base 2. If c is 10, it is log of base 10. If c is 1000, it is log of base 1000. Okay. The interesting point here is, so we can say like it is big of log of, very difficult.
C.
Yeah, exactly, log of c. But in representing asymptotic notations, right, as I mentioned earlier, right, we always ignore the constants. So if it is log of 2 or log of 10 or log of 1000, so conversion from log of 2 to log of 10, right, the conversion is easier. Like there is some multiplication, some constant value you have to multiply. So it is a constant. Again, log of 10 to log of 1000, it is also some constant you have to multiply to get that value. So basically what I'm trying to say, it is a constant, so you can ignore. So you can just say log of, big of log of, sorry, log of n, right? So this is the order of the algorithm. I hope you understood, right, how to compute the log. So when you have something which is, like when you're analyzing, right, if you draw something like this, so it is like a pyramid going down and then somewhere it is meeting. So that is nothing but a logarithm. If it is linearly growing, right, in the sense like completely for loop or completely two times the for loop, 2n, or for loop inside for loop 3 times, so it is n cube or 2 times n square, like that. So it is pretty simple. So here when it is linearly slowing down, right, it becomes a logarithmic. Okay, I hope you understood. And the third function here is power, right? Power of some value here. Started with I, the power. So here, how your, so any guesses, what will be the growth of this particular function? So this is I equal to, oh sorry, I equal to power of I.
Power of t.
Sorry?
I think power of t.
No. So the next iteration you are computing with the power of value. It is also
So
logarithm only.
log.
Yeah, it is
Oh.
also log only. I just for the confusion only, I just created like this. So I value is always you are decrementing. The next I value, right? For example, it is I equal to 2, I less than n. It is not I, you are incrementing with 1 or incrementing with 2, right? You are incrementing with some power value, right? For example, here it is same. I equal to, if I give C as a 2 here, right? It is the same. I equal to I into 2. It is the same here. It is power of 2, right? Similar like that. If I give 3 here, which is nothing but C equal to C3 here, it is power of 3. It is a logarithm value. Okay, don't get confused there. I think this one I covered. Okay, now here, right? So how the algorithm is growing here, how the function is behaving. So what we have from here, we have order of n here, right? So we know that constant work we are doing, theta of n is also fine. The next year, so this is also big of n here, right? And then what we have the next one, though it is a loop, but we know that it is going to execute it only for 100 iterations. So it is a constant operation. So we know that it is big of 100, right? Think that I wrote 100. Okay, I don't want to waste time. So what is the final output? It is 2 big of 2n, right? Or theta of 2n is also fine. 2n plus 100. I hope you understood, right? You ignore this 2 and this 100, so just big of n. Okay, let's move on. Now what about this for loop inside a for loop? So this is nothing
N
but
square.
of n square. Yes. Okay. Yeah, let's see. Next, we just completed the asymptotic notations and we are just close to 12 minutes. Okay, so
In this thing, the nested for loop, what if we have C, so consider first has I plus plus, instead of second loop I equal to I into C.
Yeah, n log n. I into
So then
I into
I into C.
I into C, I
Some
into n
constant.
log n, right? So that is what we just saw here, right? This one.
So what
Just
if
like
all the for
this
loops from first to second, I into C and second also I into C.
Okay. I into C, right? So
Yes,
it is,
yes.
yeah, it is log of log n.
Log of log n that way.
This is log n and this is also log n. So it is log of log n.
Okay.
Understood?
Yeah.
Okay, next chapter we have the mathematics. So we see some terminologies with respect to mathematical representations. So let's assume this particular case. So what you need to do is you need to find the number of digits in a given number. Let's assume that if I give 1, 2, 3, 4 as a number here. So you have to find out how many digits are there in this particular number. Okay, so how will you do? So basically, it's pretty simple. What you need to do is you need to divide by 10. So that, for example, in this number, right, if you divide by 10 and take the next number will be 1 to 4, right? Because divide by 10 means you are considering only an integer here, right? This sum should not have been something else. So you will have 124 and the next divided by 10 will be 12. Next divided by 10 will be 1. And you try to divide again 1, right? So it becomes 1 divided by 10. So it becomes 0 in terms of integers. Okay, when you're dealing with integers, it becomes 0. So what we do, you initialized sum. This is not a sum actually. Computing a number, something like that. So what you check here, you check whether n is not equal to 0, right? And then you divide n by 10. So first you have 1, 2, 3, 4, 1, 2, 4, 5. And then the value of n what becomes n divided by 10, it becomes 124 here. And then what you do, you add a sum because you're trying to find how many numbers are there, right? So first you will get 1 here. Next you will go, now the sum is 124. So what you do, again you check it's not 0, again you divide, now it become 12, n is become 12 here, the sum is incremented to 2. Then next it comes here, n is not equal to 0 because it's 12, again you divide, so n becomes 1 and your sum becomes 3. Again it goes to the next iteration, n is not equal to 0 because it's 1. Again when you try to divide, n becomes 0, but we already reached here and we increment the sum, so sum becomes 4, right? And the next iteration, this loop will fail, you come out and then you do a return. Now you tell me, so you understood, right? Find digits. So this question can come, how will you find a digit? I will show another approach. How will you find a digit? So this is a simple one. So any guesses what will be the, growth of this particular function?
O of log n,
Log n, right? Why?
because we divided
one
based
more
on the
thing.
10.
Yeah, that log n is fine. What is the base of that log?
10.
Yes, but it is a constant, so we can ignore. So it becomes log n because every time you are dividing by 10, right? So it is linearly, growing, or linearly you can see form the graph, right? So it becomes a pyramid again. So you can see. So that is the reason it is a log of n. Okay. Yeah, the same function. What I can do with respect to recursion also. So yeah, so when I'm saying it is the order, right, there are two things which I think I'm not, I think I forgot to cover. I touched that topic, but I'm not sure whether you guys have understood that. When I say order, right, the order is the general term basically we use for two things. One is the space as well as another is the time. Okay. It can be, and now what I am referring here, right, only with respect to time. And that is what I'm showing, how long this will take. I'm not talking with respect to space. When someone asks like what is the space complexity, right, then you need to get into calculating the order with respect to the space. For example, like this integer, right, is going to take some space, and then the value of n here, anyway you got some from integer, and then the return is you're not going to take much. So like this, so the computation will be based on like that. So but what I am explaining here, order is nothing but a time complexity, right? How much time the algorithm is going to take. And what I have seen over the years, right, the examiner is not that interested in the time space complexity, and they are more interested in the time. There were some days like earlier when people used to work on smaller devices and the memory constraints were there, but nowadays it is not the big challenge, but the challenge is only with respect to the time the algorithm takes, right, to execute. Okay, so doing the same thing, finding a digit with the help of recursion. Okay. I hope you guys know, right, how the recursion works. So recursion is basically it tries to make use of the function stack, how the function being executed. For example, let's assume that you have a stack here. And whenever you are trying to compute or analyze an algorithm, right, always try to take a smaller number. For example, like n here, right? If you take a larger number, right, there are more chances that you will get confused. Okay, either you will get confused or you will confuse the examiner. So what you try to do, you try to take some number which is even less than 5 or less than 8. No, even don't go till 10 also, because that becomes very large. For example, I will give one example here which you will understand. Let's find the digits with the recursion. So let me take one example here, 1 2 4 5, the same example. Okay, so what you are trying to do here is, right, so the function will be called for the first time here, 1 2 4 5, right, and it checks the number is 0. No, it is 1 2 4 5, so it does not return 0, but it comes here. What it does is that it again calls the same function with the different value 124, right? But the return is not completed yet because it is waiting for It is waiting for this function to come back. So what is the return value? 1 plus, right? Function of 1 to 4, right? No, 1 to 4. If you find me in some class, right, I could have done it fast. Okay, if I have some blackboard or something. Okay. And now you call this particular function with value 1 to 4 here. Now 1 to 5 is gone because we just divided that with the 10 and we got into a stack here with the next execution. So when we come back to again with this, with the value n here is 1 to 4, 124, it's not 0. Again, what we do, we again divide by 10. So now what happens? What value you have? 1 plus function of 12, right? Function of 12. So the recursion works with the function stack. Okay, just try to understand that. And if you do like this only, you will be able to come up with the better analysis or even analyzing any function, right? This is the right way. Okay. Next, what we do, again, the same function is called. So you go back and again call 1 plus function of 1 here. So 12 divided by 10 is, you'll get 1, function of 1. Okay. Now 1 is not 0, so you come back again here. So again, one more function will be called 1 plus function of 0. This time it becomes 0. Okay. Okay, now value is 0, so it returns 0. So you get 0 here, right? 1 plus 0. And that 1 plus 0 will be returned here, which is nothing 1. Okay, and here function of 12 is nothing but 1 plus 1, 2. And this function of 124 is nothing but 1 plus 2, 3. So 3 plus 1 finally will be returned here from here, the final call, where the function returns. So it becomes 4, correct? 1 plus 3. So this is how it becomes. Now, can anyone guess what is the, like order of this function, how the function is growing, order of the growth?
1.
1. You mean to say big O of 1? No, it is not like that. No, not 1. for sure.
Big of n power n.
No, it is not like that. N power.
Is it log base n?
You're a bit close. Not base n. I mean to say. You see this 10 because I'm dividing always with the 10. No.
Okay, log base 10.
Yeah, log base 10. So it is big O of log base 10. It is the same thing. I'm doing the same operation here. Only thing is that I'm, instead of while loop, right, I have just called a recursion just to confuse you guys. Okay. So if my function grows, right, so the division will be like order of 10. Every time it will be sliced into a 10 times, like what I can say, like power of 10. I think you got my point. Okay.
So both traditional and recursion have the same time complexity.
Not always in this case.
Okay, understood.
Not always. Yeah, not always. This is a very simple algorithm. So you luckily got into the same thing. But
Okay.
there will be some complicated algorithms, right, where you use a recursion, which you find, though it looks simple one function writing, the recursion, like wherever you are very confident, right, then only use recursion, because things may go horribly wrong in recursions, and the analyzing will also become very complicated when you have a larger number, right? But the function and the code wise, right, the compact thing, right, the recursion gives a better thing. But if you are not very confident, go with the normal approach only, because now you saw it, right? Even though it is a recursion, even the code size is small, but the order of that particular function is taking the same time. Unless you are sure that you are writing a very good algorithm where with recursion the order is like coming down, so go for it, unless and until you don't find any much different, than better you do a linear thing, right? Debugging is also much easier there. Okay, factorial of a number. Factorial, right? N into n plus 1. Sorry, n into n minus 1.
Yes.
Yeah, factorial, n into n minus 1. Okay, what is the order here?
N log n.
Sorry? N log n,
Or maybe log n.
Order of n.
order of n. Who said n log n or log n? Any justification for the log n thing here?
It will be like log n only because we don't know with what number it can divide. Sorry, it can, number of times it will go.
But why you are using log here? I'm not dividing the number, right?
Yes, yes,
OFN.
yes, yes.
Log will come when it is
O
logarithmic.
of n. O of
Yes,
n.
big of n, right? Because here, let's assume this 5 right here. 5 case, right? 5 into 4 will come. Then 4 into 3 will come. 3 into 2, 2 into 1. So it is like incrementally you are going. So based on how much n is, right? So n number of times you are going to multiply that. Correct? So it is big of n only. Okay.
So
Check.
only during when the divide is happens, the log comes into picture.
Divide as well as so here, right? Yeah, this is a divide. I gave one more example, right? Where
Or multiplication also somewhere.
there was a power, right? Where
Yeah.
So the for loop, I was like slicing down with respect to this value. So I was, for example, if I want to increment, right, I will be incremented by number +1 or +2. It is like you are going a incremental way. But here what you are doing, you are directly jumping with some value, right? So you're not going to compute with
Yes.
all the items in that particular array. You are jumping, right? So the jump is nothing but you are basically you're slicing it down. It is like a linear logarithmic way, right? So I'm not sure you understood or not, but I find difficult to explain that. You guys understood what I'm explaining?
Yeah, yeah.
Understood, right? Okay, great. Okay, check if number is prime. Prime and even right, it is pretty simple one. So very simple logic I have written. What we do is we declare number as a prime first, and then we start one anyway is even number, right? So we know like we start with the 2 and we go till n by 2 in J++, and then we check if that number n, whichever we need to check right here, is divisible, and sorry, the modulo of that is 0. So basically, which is a prime number. Otherwise, it is not a prime. So now you tell me what is the like order of this function?
N into
Order
log
of
of n base 2.
N into log of n base 2.
Order of n by 2
N
or
by
order of
2.
n.
Order of n. Very varying answers I'm getting. Okay. Madam, someone's told, right? Log of n into log n you said, or you said log of n with power base 2?
If it is one number, it is log of n base 2. If it is like a group of numbers, it is like n into log of n base 2.
Group of number means I didn't just
Like-
one number.
like
This is the function.
Just one
This
number
doesn't-
means, yeah. Or log
is
of n
that?
base 2.
Yeah, it is log of n base 2, right? Because you are in each iteration you are dividing by 2. So try to understand this thing, right? Whenever you are doing a divide or you are jumping, right? So then it is like you are not going a linear way. You are sorry, you are not going incremental way. You are going with log, like hopping it, right?
We are not dividing it by 2, right? We are just checking if it is less than half of the given number.
J is less than yes.
So it will be order of n by 2
Yeah, you're
or
right.
order of n.
N by 2 G plus plus. No. We are not just
So
a
you
minute.
mean here the iterations are reduced?
Yeah, that is what I'm trying to say. The iterations are reducing, right? We are not going for the complete iteration here. We are only doing half the iterations. Correct? N by 2, and that n will be changing every time here. First n will be 2. Next time you will be increment the value of n. Sorry,
We're
value of
not doing anything with n, right?
sorry, you are not doing anything with the n, correct? But your j value, right?
J value is not reducing in each
yeah,
iteration.
yeah, j value is not reducing. It is just a comparison.
Hmm.
Yeah. Correct. So it is not a log n. That's for sure. Correct, no?
Yeah,
Did-
it is n by 2
Yes,
or
sir. My mistake only. That's
Yeah.
correct.
Yeah, it is big O of n only. So even I assume like that because I just confused. I thought this j is uh, uh, getting decremented. So yeah, I'm sorry for that. Yeah. Okay. I'll be sharing the slides. Maybe you people can analyze more and then see. And if you have some different justification or different results, yeah, definitely we can have a discussion on Saturday because I have a lot of things to cover. And it is already 6 minutes ahead. We just passed, and I just want to stop here. And we'll continue tomorrow with further. Okay, I think only one more thing is left out. Finding a E palindrome. Okay, the intention of this these slides, right? The mathematics portion of the slides is not to find the order of the function. It is to these are all the exam questions, like how you find the number of digits in a given number, find the number of digits in a given number, n value, right? How many numbers are there? So how will you solve that problem? So first you need to understand what you need to do, right? And how you can do that. For example, this has a two answers. One is that you can divide by 10 and then add the values to n, which I just showed right here. But what I'm trying to explain you here is that what examiner will be looking. They will be looking like how concise or compact or well code you'll write, so that it is again easy for you, or if there is a problem in the code, you can detect as well by like analyzing or taking some small number and then seeing that whether you are getting exact value. For example, the number can be 0 right here. Number passed is 0. So in this case, what is the sum value? Sum value is 0 because n is not equal to 0. Then only it will go, otherwise it returns 0. Correct. So it can be 10,000 also. In 10,000, how will you define? Right. So you will have a simple answer here in that case. Correct. But let's assume that instead of int, you took some double value here. Correct. The programming mistake can be. That time this program will not have a right value, right? Because you want to ignore few things. That is, for example, 1 by 10, right? So that time you don't want to take any fractional values here. You just want to ignore that and you want to get a result of 0 itself, right? So that way you need to try to understand the problem first, then just getting into writing a solution for that. So that will give some hint to you. Okay, and the intention of this mathematics, whatever I put mathematics here, right? It is the logic what you are going to use here, finding a digits, right? What math logics you will use. For example, 1, 2, 4, 5 if you have, and if you want to find the digits, how will you divide, right? You can divide with hundreds also, you can divide with the 10,000s also. But what we want, like we just want to take number one by one from here. Okay, and then count 1 like this, 2, 3, 4. You may have some logic, like you can start counting from here also. Correct, but that will become difficult one. My suggestion is that you start from here. So this is a simple one. So you try to, instead of getting into writing a code, right, you try to understand how you can get a exact value and from which side you need to go first. Okay, similarly, this particular one, the recursion one, it is pretty easy. You have a very confident, like you can use recursion and solve by, the logic is same in both the places. Logic is same. You are going to divide the number by 10 and then take digits one by one until you reach to 0, right? But it depends like how confident you are with the recursion as well as with this particular approach, right? So here again, you can take for loop also. If you are pretty sure, like you can do that one with the for loop. Okay, but I think best suitable is a while loop here. You also should know like which loop to use where. Okay. That comes only with the practice. Okay. Again, factorial, given a number, finding a factorial, you'll find n number of answers in Google, which also lead to the same kind of solution. But sometimes it won't flash during the examiner, right? When you're facing the exam. Factorial means what? You will be thinking what exactly means factorial like that. So, right, instead of, like always relying on Google, try to understand the concepts like factorial, what is a palindrome, what is the prime number, all that things. Okay, prime also we checked, and there's something called as how you print a prime numbers. So I just covered, this is particularly finding a prime number. No, this is actually checking a prime number, whether the number is a prime. If you want to print slightly different logic, I will share the slides. I don't have much time to explain all these things. Then there's something called as East palindrome. You know what is a palindrome? Let's see if this function 1, 2, 3, some number 3, 2, 1. So if you start reading the bits from left or right, it should lead to the same things. So here 1, 2, 3, and then 3, 2, 1. ABC, CBA, right? So it is a palindrome. So that time you should return true. 1, 2, 3, 4, 5. It is not a palindrome. 1, 2, 1, 2. It is also not a palindrome. 1, 2, 2.
Order of n by 2.
No, I didn't ask the what is the order of n by 2? I didn't understand.
It is like a time complexity. First
No,
number,
I'm
last
not asking
number.
the time complexity here. So the
Okay.
intention of this one is not to find the time complexity, but to answer the question. If examiner asks you, write a function to show that whether it is a palindrome or not. Given a number like this, your function should execute and tell that whether the number is a palindrome or not. So how will you calculate that? How will you find?
First,
whether particular
divide
number-
the numbers, into two half
Okay. How will you divide a number into two first?
with its length,
You don't know. N is given. How
yeah,
will you
n
find
by
the
2.
length of n is nothing but you have to find digit first. Correct.
Sir, you can
Okay.
convert that number into string, and based on the string length, we can compare first character of the first string, character of A,
No,
0
no.
to length -1.
That is not a good thing.
We can use 2 pointers here, actually.
It
So
is just a number, sir. It is not a linked list. I will come to that linked list. Then I will catch hold of you.
Yeah, we already wrote last time find digits with recursion. That we can use to find
Okay.
the number of digits is there.
Okay.
So yeah, we'll know how many digits are there. Then we can divide with divide by 2.
Okay. We can do
Then we
something
can
like this.
compare.
Okay. Okay. Tell me.
Then yeah, we can compare from for first one and the last one. Again, the second one, the second last one.
Hmm.
So that way we can put it in a for
Or
loop or while.
You can do one more thing like this. You can anyway, you know how to check the last number, right? Divide by 10.
Yes.
Okay.
Yeah.
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 You
got
can
it.
store that, and when you reach the end, right, you can compare these two things, the first one and the last one. Similarly, the second last one and the second number. Similarly, the third last one and the third number, something like that. If the number is like this, the function is like this. What I'm doing, I'm just checking the number is greater than 0 because that is what I need, and I have taken some integer value. The reverse is 0 initialized, and the remainder is also initialized to 0, and the temp is n, which is nothing but the value which I want to find. So what I will do, first I will find the remainder, which is nothing but the last digit. Okay, so 1, 2, 3, 4, not 1, 2, 3, 4, 1, 2, 3, 3, 2, 1. So this is a perfect palindrome. So you always try to take some perfect number and then see your algorithm is how it is behaving. Then you see the negative value, how it is behaving. Then you see the end cases. So this is how you have to start verifying, validating your function. So what is the R here? R is 1. Now what I will do, I will check the reverse. Reverse is nothing but reverse into 10 plus R. Correct?
Yes, sir, yes.
What is
Yeah.
the reverse here? So reverse is 0 only.
Yeah.
Right?
0 plus 1.
Yeah. 0 plus 0 into 10.
One.
plus 1. So it is 1.
1.
So the reverse also should be 1 only. Okay. And that value first I am saving it in temp. So n is not this one, right? So again, you get into iterating again, same thing, and keep checking the reverse value. Finally, you check. So basically what I'm trying to do here is, so this is the temp value, right? Now what I want to do, I want to reverse this number, right? And I want to stay after reversing, right? It becomes 1 in this iteration. Second iteration, it becomes 12. Okay. In third iteration, it becomes 123. In fourth iteration, it becomes again 1, 2, 3, 3, right? It is, you are going like this 1, 2, 3, 3, 2, 1 like this. Finally, it ended because n is greater than 0 because you already reached. And then you check with the temp because temp anyway, you stored it to the same number, right? And then the reverse, whatever you calculated now with this particular function, correct? You are reversing this number, right? You are reversing and you are putting it front, and then finally you got the output like this. Let's assume that your function is something like this, and you want to check whether it is a is palindrome or not. So in this particular for loop, what you're doing, what you will get first iteration, you will get 4 because you're trying to reverse the number. Then you will get 3, then you will get 2, then you will get 1. And then finally, what you'll do, you try to compare these two numbers here, temp equal to reverse, correct? It is not same, right? Then you return false. But in this case, where the positive case, you will get a perfect number. So you return true. Guys, you understood what I'm saying?
Yes, yes.
So
Yes.
basically, you reverse the number and you try to store here in the reverse string. And again, you are dividing by 10 every time, so that you take digit by digit, correct? And then form a reverse number. And you understood why you are multiplying by 10 all the time? I think you-
For adding to that reverse, like we
Yes.
cannot add it directly, right? Like if you add, it will become 1 will become 2. So we cannot do that.
Yes,
So we should add 1 into 10, then plus 2, then 12.
yes, yes. Yeah, correct. Right. Okay, I think it is already 9:18 now here. So I hope you guys had a good session so far. So tomorrow I will try to cover arrays. We'll see what exactly the arrays are. The intention here is with respect to examiner's point of view. What kind of questions can come from arrays, and how you can understand try to understand the question first, how you can understand the question, and if you have doubts you can ask the examiner. And there are some standard questions which comes from the arrays section, so that I will explain to you. There could be some questions which I may not have covered, but you guys will feel like it is doable, right? So how you can approach that, so that also I will cover. And then we'll see a few other things. For example, what we have after arrays, we have a lot of things. We have logical operators here, and then there are searching and sorting. Examiners will be more interested how you do a search, which searching technique is best suitable, which sorting technique is best suitable, when and where, all that kind of things will come. We touched upon the recursion. We'll go much deeper there. Then strings, don't worry about this. Then we have a matrix, then linked list. Here I try to cover array list, linked list, all that things. Then there are interesting questions comes from stack and queue. Okay, stack, like how simply you can implement a stack, and then how you can do a boundary checks of the stack. The top of the element is not -1, and the length is the elements in the stack, right? It should not be an empty stack. So all that things. So there could be very interesting questions from this point of view, right? Where you can see given a stack data structure. So the examiner may ask you to implement a queue. So how will you do that? So you need to understand what stack does, right? So basically stack, what you have is you have only one end. So it is what we generally call it as first in, last out. So the element which came first, right, is the one which is going to go last, because we have only one end for that. Insertion and popping is pushing and popping is happening from one end only. But whereas queue, right, it is double-ended. So we have something called as front as well as a rear, right? So the elements may be coming from one end and they will be getting out from another. So the data structure we called as first in, last out, first in, first out. So the element which it is queue. So basically you are standing in a queue and the queue is processing based on the order of, right? But stack is reversed. Given a stack, how will you implement a queue? So this is the question asked by an examiner. So how will you solve that? Any guesses, guys? Or you want to wait for my session to come to the
Sir, can you repeat the question once again?
The question is, you have to implement a queue given a stack data structure. So you have a only stack, but you have to provide an operation what queue does. Question is clear?
We can use DQ method, right?
Madam, let's assume that you don't have any methods or you have to implement that methods. How will you implement the DQ or NQ methods? You have to write your own data structure, madam.
We can take two stacks and that we can.
Yeah.
No idea, Feroz.
Yeah, I think the madam was a bit clear, a bit near to the answer. So what you can do is you can take two stacks here. Okay. So one we can call as a pop stack and one we can call a push stack. Okay. So once element is inserted, right? So you can insert into one stack here. Okay. And if you are inserting, you can use the same stack, keep inserting, no problem. Stack is behaving. And now when you want to pop it out, right? So you don't want to pop out 3 here, right? You want to pop out the element which went first. So what you do, you use the another stack here. So you push the top element until you find the last element, right? So you push 3, then you push 2, then you check whether it is the last element. Basically, you push till the stack, this stack becomes empty. So you push 1 also. Once you realize the stack is empty, right? You pop up the 1. So basically, it is like the element which came first came out first, right? Now what you have only 2 and 3. And now this stack, you again push it back here. And then same perform the operations on this. Again, you want to pop, right? So again, you send it back here like this. But telling is easy. Okay, we'll come to there and we'll see like how you write a function to implement that. Okay, so if you understood the logic, means half the battle you won, but remaining half is the one which the examiner may be interested that what functions you'll write. The more important thing is that the boundary cases, how you check the boundary cases, because examiner will be interested into giving you some input value where your boundary conditions will fail or you might not have considered that cases, right? So that part of things. So here it is not that complicated one, but I will cover some topics on that. So okay guys, I think it is becoming a bit late here. And I would like to take break.
Thanks, Feroz.
We'll cover tomorrow remaining things. Yep.
Thanks, Feroz.
Bye, Satish.